This is a video tutorial on factorizing and specifically how to factorize algebraic equations. So I have 4 examples and we're just going to work through each of them, and hopefully by the end of it factorizing will make more sense. So in the top right hand corner you can see that I have the definition of a factor. So a factor is a number or expression that divides a number or expression evenly. Okay, what does that mean? Take, for example, you have the number 35. We know that, for example, this is made up of numbers 7 and 5. So we know that 7 and 5, when in product, equate to 35. So we say that 7 and 5 are factors of 35. So they're numbers that, when multiplied by each other, equate to that number. So another one would be if you have 10. So 2 multiplied by 5, because when in product that equals 10, 2 and 5 are factors of 10. But it doesn't just have to be the first set. For example, 1 multiplied by 10 equals 10. So 1 and 10 are also factors of 10. So now we're going to apply that same logic with algebraic equations. So the first example up here is variable x to be squared plus 5x. So this is an algebraic expression, and the variable in this expression is x. So what you have to look for when it comes to these types of expressions is what is common to each section of the expression. So what I mean by what section would be this and this. So by looking at these two sub-expressions, you can see that x is common to both. Now if I take an x out of this expression, x squared, I would just be left with an x. And if I take an x out of this expression, 5x, I would be left with 5. So this is now the result of factorizing this expression, the x squared plus 5. So you can see that we have one item, one factor in product with another factor. Going on to the next one, it doesn't matter what the variable is. Here we're dealing with x's, here we're dealing with n, s, p, m, and r. So there's multiple variables here, but the same principle stands. You have a look at this expression and see if there's any way that you can make it look a little bit simpler, or section it in such a way that factorizing will be a lot easier. Well, I can see that there's a common value in these first two sub-expressions and also in these two last sub-expressions. So why not split them up this way? So look at this first expression. What is the common variable within that expression? It's n. N is here and here. So if I were to take n out of this first item, we're left with just an s. And then you get the plus from in here, and taking n out of this second item, we're left with p. So once again, we have one item in product, one factor in product with another factor. So these now are shown to be the factors of this first part of the expression. Now moving on to the second part. So we don't forget our minus in here. What's in common with these two sub-expressions? We have an m. Taking an m out of the first item here leaves us or, plus, and then a leftover s. So again, we have this factor in product with this factor. So they would divide in evenly. The next example, number 3, is slightly different to the other examples so far. If using the same ruling that we used for these, on example 3 it wouldn't work, as we cannot see, for instance, an x that lives in this part of the expression as well as this. So you would say, well, what is there to do that? Well, there's the factorization by square. So what we can see is that each item in this expression is a square of a number or variable. So here, x squared is variable x squared, and the 49 there is a square from either 7 plus 7 or negative 7 squared. So we can then use that fact to split this expression up into two product factors. So the first factor, the first square would be x minus 7. So that's the first factor. And then the next factor would be x plus 7. So going off the definition, you can see that a factor is a number or expression that divides a number or expression evenly. So this value divides into x squared minus 49 evenly, making it a factor. Now, how did we determine the signs? Well, if I had a plus in here and a plus in here, if you multiplied that out, you would see that you'd be left over with an additional algebraic term. So to verify that these are the correct factors, you could just multiply it out and prove it to yourself. So if you multiplied it out, you'd have an x squared multiplied 7x minus 7x minus 49. This would cross with this, leaving x squared minus 49. So we know that these are the correct factors. If this was a positive, this sign here would be positive and you'd be left with a 14x expression in the middle. Now the final example is similar enough to this second one over here, as it has more than one variable. So the way we would go about this is looking at the expression. We can see an x variable here and an x variable here. So we know we would take out the x value. But in addition to the x value, we can see that 4 could be taken out of here because it could also be taken out of here evenly. So we can take out the 4x, and then that would just leave us with a single x here, and then it would leave us with, well, if I take a factor of 4 out here, we'd be left with 4. 4 by 4 is 16. We've removed the x from this expression, leaving us with y. So we have one factor in product with another factor. For all these examples, to verify that you're correct, all you do is go in reverse. You could multiply the factors and see if you get the original expression. So using that logic for this last example, let's multiply 4x by x. We get 4x squared, which is our first item back from this expression. And then a 4x multiplied by a negative 4y would give us minus 4 by 4 is 16. X by y is x, y. So that brings us back to the original expression. So therefore, each factor we know would divide in evenly, as when in product with one another gives us the original expression. So I hope you enjoyed that video. I hope it made sense. I'll be doing a whole series of algebra videos, a full playlist. I've had 3 videos prior to this from the very beginning of algebra, and I'll be working my way through. So if you enjoyed, if you've learned something, maybe give it a like or a subscribe, and with that you'll be able to keep on top of your algebra and hopefully learn something along the way. Okay, thank you. Bye.